we're learning about commercial unit of energy. It's a practical aspect. It's good for us to understand this. First of all, why do we need a commercial unit of energy? So we already have energy that is expressed in terms of joules. But why do we need something else? To understand this, let's take up an example. The unit joule is too small and hence inconvenient to express large quantity of energy. The best thing to do this, understand this is with an example. So we have an example wherein I have a single light, which this is of 20 watt, which I switch on for 10 hours a day, almost for 25 days for a month. So the total energy consumed for those 25 days or on an average per month would be how much? Let's calculate that. So we're looking at the energy consumption for those many days. So the energy is given by power into time. And here the time frame is huge. So power is how much? 20. Time is 10 hours into 60 minutes into 60 seconds for 25 days. That would be your time. Agree? Now let's calculate this. So we have 2 into 1 is 2. Let me take the zeros. 1, 2, 3, 4. 10 to the power of 4. 2, 36, 50, 18. So this would be 180. Agree? Am I correct? 36, 50. 3650 is 100. So sorry, this is 00. So this is basically 18 to the power of 6. Okay, guys. So many joules. So this would be the energy consumption of this tube in a month. If this appears in your bill, how many people can understand this? Forget about exponents. Let me express in terms of 1, 2, 3, 1, 2, 3. In terms of zeros. This is for a single tube. Obviously in a house there will be more than a tube being used, and fan and TV and fridge and heater or so on and so forth. Is it viable for a house to have such values? Such huge bill, right? It won't be feasible. So in expressing the energy consumption of this bulb, right, of this LED, is not feasible. Can you see that? A single LED itself. Think about all of them put together. It is not convenient. So it's not convenient. The unit of joule is too small and hence it's inconvenient. As you can see, it's not convenient to express large quantity, right? This is a large quantity and that to a single tube, single LED. Think about all the things, other things that we use in our day-to-day lives. So it's not convenient. So the replacement is, we have something called as kilowatt hour, also known as units. Many people get confused that there is a watt, so this has to do something with power. Yes, it has to do something with power, but first thing it has to do with is energy. Okay, so it is the alternative way of measuring energy. I hope you guys understood this part, that it is to do with measuring energy consumption that happens in our house, in our industry, in a school, in a college, in an office, right? It's a commercial way of expressing it. The funda is this. Okay, now what is the symbolic representation of kilowatt hour? It is kilowatt, capital W, and then R in this way. Okay, that's it. So that is your symbolic representation. So let's take up an example to understand exactly how much is a kilowatt hour or 1 unit in terms of joule. So how much is one of this? So some people write H, I write HR, some people write with a space and some don't. So it's left to you guys. But yeah, I think a bit of space is helpful. Okay, yeah, coming back. So we have how much is 1 kilowatt hour or 1 unit in terms of joules. So let me explain what is 1 kilowatt hour. So let us stick to the standard wherein I leave a space. I don't remember exactly all the books leaving a space. I'm just trying to recall that. Anyways, as of now, we'll leave a space. I've written it over here, I guess, for a reason. Maybe your books are telling that. And some of the foreign authors, they don't leave space, I guess, if I remember right. Anyways, I'm not able to remember. Okay, now what does it mean? See, this is kilo. right? This is watt and this is hour. Okay, time. So this is kilo is nothing but to do with 1000. Kilo is 1000. Watt is to do with power, and time and hour is to do with time. Right, guys? So this clarity should be there. The next thing that we need to understand is 1 kilowatt hour is 1000 watt hour. We'll do it step by step. Now, next thing is 1000 watt hour is nothing but 1000 watt into 1 hour. Okay, again, we're just showing step by step. Right, all of this is the same. 1000 watt into 1 hour in terms of second is 60 into 60 seconds. Agree? And so we have this to be 3 zeros, 4 and 5. 36 into 10 to the power of 5 watt second. And watt second is nothing but your joule. Okay, guys. Right? 36 into 10 to the power of 5 joule. This is a question that is actually asked in your books, but I took it as your flow of the topic. Okay, guys. So this is important for you guys to understand, and you need to write this in your exam. And please understand what is happening over here. Okay, kilo is 1000. 1 hour, I've just written it as 60 into 60 seconds. And yes, it's okay to write in this manner. Nothing at all. I mean, it's nothing wrong over here. And all I did was multiply and express in terms of, exponent. And watt per second, not per second, sorry, watt into second is joule. Power into time is your energy. Agree? So this many, if I put it as a zeros, number of zeros, 1, 2, 1, 2, 3. This would be your energy in terms of joules, but this is equal to 1 unit of energy. So every unit has this much of energy, this much of joules actually. Okay, so whenever you see any commercial bill, electrical bill, remember 1 unit, there will be unit written over there. I should have put a screenshot of the bill. So this would be in terms of this many joules, Okay, guys. So this is something that you guys have to remember. Okay, that value comes in handy for a day-to-day life, Actually not, but you guys got what I mean, right? You'll be able to understand what is exactly happening, how much of joules is being used, and you'll be able to compare. Again, if you're curious, it's useful. Okay, so you have to write everything over here. It will help you understand things better. This is an LED.